Okay, John, please introduce the speaker for tonight. Thank you very much, everybody.
Okay. Back in 1993, I remember the reports were that an asteroid had broken up and it was heading toward Jupiter. And at work, they said to me, well, will we see anything? Will we see anything? Well, I was the authority of astronomy, and therefore I said, no, there's no chance of that. Don't worry about it. Don't get your fur up. Absolutely no chance of it. Well, tonight's speaker, Gary Donahue, is a member of NJAA, and he is going to tell you otherwise. So please welcome Gary Donahue.
Thank you. This is quite a turnout. I'm very excited to be able to speak with you all today. I'm going to warn all the people in the front row, I get loud, so if I step on you, I tend to be very animated. We're going to move pretty quickly because I have too many slides for the amount of time that they gave me, but we're going to do our best. Certainly, if you have any questions, let me know. Ideally, if you could save them to the end, that would be great, but it's a free-for-all. We're going to do what we want. So I wanted to start because if any of you have watched any of the NJAA videos, they're kind of great. And they're filled with PhDs and like people who have actually walked on the moon and designed telescopes. And I'm like, who am I? So I decided that I would do a little introductory and see why should you take me seriously? And this was actually the best I could come up with. All right, those are all me. So I have written 5 books, so that's exciting. None of them have to do with astronomy. I have a lot of hobbies, none of which are about why we're here. I do love astronomy, though. Those are actually all my telescopes. I took all those pictures. This is a thing I designed in 3D so I could actually put an iPad on top of my telescope to take light frames or flat frames. Those are also not all of my telescopes. I have more than that. I am also a qualified observer, which means I am trained to use the big telescope upstairs in the dome. And as John said, when we're done here, if you get a chance, go up and check it out because it's really, really cool. Those of you that are NJA members will probably notice that it looks a little bit different in this picture because it's really, really blue. I took this picture in 2004 when my wife and I came here with our kids, who were like 10 and 11 or something. So we've been coming here a long time, and it is absolutely a great place. All right, but seriously, I'm Gad. A lot of people call me Gad. My name is Gary A. Donahue. That's my initials. That was my username that I used on systems for a long time, and that is my beloved C11 telescope that my wife gave me for my 60th birthday because she's awesome. All right, now why are we here? Because in 1994, a comet slammed into Jupiter, and it was an absolutely mind-bending event. And John is absolutely right. A bunch of us were like, you're not going to see anything. It's, don't worry about it. Well, I'm going to explain that. But first, I want to talk about Jupiter. So Jupiter is the brightest planet by far. You've probably all seen it, whether you knew it or not. Not the brightest planet. That's not correct. Venus is the brightest planet. It is the largest planet by far. It is the biggest of the gas giants out past the asteroid belt. Jupiter is the Roman equivalent, the name that matches up with Zeus, and is also called Jove. So have you ever heard the term by Jove? That's what it means, Jupiter. And that's why we call the moons of Jupiter the Jovian moons. All right? Cool thing about Jupiter, and we're going to come back to this a bunch, Jupiter rotates every 9.9 hours. This is an enormous planet in the sky. And every 10 hours, the entire thing zips around. That's less than half of an Earth day. And this enormous planet is zipping around. This, by the way, was taken by an amateur astronomer. They took these pictures and put it together in an animation. And it's just so cool. If you're out there with a telescope and you're looking at Jupiter and you come back and look at it an hour later, it's different. And that is a mind-blowing thing to witness firsthand. It is so cool. All right? This is actually an image taken by Voyager as it was hurtling its way out into space. And brilliant thing about this was they were heading right at the red spot, so they took a photo once every 10 hours. So it looks like the red spot is almost standing still, and you can see all of the bands swirling around in Jupiter. Brilliant. You got to remember, this is 1979. We didn't have all the cool tech that we have now. So this was absolutely a mind-blowing thing to have happened back then. I said Jupiter is big. Jupiter has 2.5 times the mass of all the other planets combined. It is unfathomably large. It is difficult to comprehend just how big it is. Because it's so massive, it has a lot of gravity. And it attracts things out there in the solar system and gobbles them up, which is great because then they don't come slam into us. Yay. Sometimes it also slings them to Earth, but that almost never happens. So we're not going to talk about that today. All right. It may have actually eaten multiple protoplanets. A protoplanet is from the early days when a solar system is being developed. It's just a disk of gas. All that stuff is rotating around. Well, in the young days of the solar system, it is hypothesized that Jupiter, which actually starts out here, actually sort of flew into the inner part of the solar system and started gobbling things up. And then Saturn got kind of wrangled up in it and formed something called an orbital resonance. An orbital resonance is something, a simple way to describe it is every time one planet orbits twice, the other one orbits 3 times, right? They're sort of like clockwork, like a gear. So the theory goes that Saturn and Jupiter formed an orbital resonance, which then sort of swung them back out to where they are now, and then they sort of stabilized. If that's true, then Jupiter is responsible for the inner solar system being cleaned out so we could sit here in peace and harmony, in theory. All right? So it's only a theory, but I really dig it. And one of the reasons I really dig it, because when I was doing research for this, I discovered this picture. And this is an actual picture of a remote star system that is a protoplanetary disk with a gas giant 5 times the size of Jupiter, which is already enormous, gobbling up the gas that's in the protoplanetary disk. And this is just a mind-blowing image to me. I freaking love this. So in short, Jupiter is a planet-eating monster. Anyone know what that is? Anyone not know what that is? Star Trek original series, the Doomsday Machine, right? I picture there's an age limit where people are going to go, nice! And be like, I have no idea what he's talking about. Okay, so that's Jupiter. Let's talk about Jupiter's moons for a minute. John talked earlier about Galileo. In 1610, Galileo pointed his little telescope up at Jupiter and went, well, that's weird. There's 4 little things around Jupiter. And he went back the next day, and they were in different positions. So he actually sat there and plotted all the positions of these things and noticed that they were moving and determined that they were orbiting something that wasn't the Earth. So now, remember, Earth is the center of the universe back then. And all of a sudden, he did the math, he made the records. Holy crap, there's something else out there with things orbiting around it. This was a groundbreaking discovery. Cool thing is, oh, did I miss it? Yeah. So he named them actually the Medicean stars after his the guy who was giving him money to do science. And later on, they actually renamed the moons to Io, Europa, Callisto, and Ganymede, which are Jupiter's mistresses, right? When you go back into mythology. So the moons were named after Jupiter's many, many mistresses. Jupiter was a bit of a player, if you know what I'm talking about. Okay? Today we know of 97 moons. The cool part about that is, a little bummed you can see I messed with that image there. The cool part is that with a very modest telescope, you can see them. You can see them with binoculars. The problem with binoculars is it's hard to hold them steady, right? At least it is for me because I'm old and my eyes. But you can see them. And if you pull up an app on your phone, you can figure out what moons they are. And you come back the next day and they moved. You can see them orbiting. You can see all this stuff happening. It's really, really cool. You can see them in binoculars, but they won't look that cool. Quick word about the moons, because I find this fascinating. This is Earth's moon. Io, Callisto, and Ganymede are moons of Jupiter, and they're all bigger than Earth's moon. Not only that, this is Mercury. 2 of these moons are larger than a planet in our solar system, and they're orbiting Jupiter. So Jupiter has amazing gravity. Jupiter is its own little system up there. Remember now it's got 97 moons all zipping around it. All right, so there's a lot going on with Jupiter out there. Now, I want to take a second to talk about Galileo's telescope, because we like astronomy, which means we like telescopes. You saw the picture. I like telescopes. So these are Galileo's telescopes. And any of you that have telescopes and have been frustrated by your optics or your mount or your computer or all of the super cool tech that we're using, these are Galileo's telescopes. Galileo's telescope had a focal length of 980 millimeters, it's almost a meter long, and an aperture of 15 millimeters. That means it's f/65. Nobody would buy a telescope today that's f/65. That's nuts. This is a US dime. A US dime is larger than 15 millimeters. This is the smallest telescope I own, a Takahashi 60 millimeter, and that's the dime sitting in front of it. Now, I came with props because I made a functional replica of Galileo's telescope. This is a PVC tube. These are 3D printed parts on the end. I bought lenses from Thor Labs. This is a functional telescope, and it is absolutely awful to use. Still awful. Absolutely awful to use. Everything's upside down. It's 15 millimeters. Really, really tiny. So just remember, if you're having problems with your telescope, Galileo changed the world with an f/60. Dust, frozen CO2, carbon monoxide, ammonia, some other stuff. I took that picture in my driveway over my house, all right, in 2024. There are different types of comets. There's short periodic comets, sometimes called periodic, and there are long periodic comets. This is actually Comet 2025 A6 Lemon, which you may have heard about because it is visible outside. Well, it would be if there wasn't any clouds. But this is this comet has a period of 1,350 years. So it's coming in, zipping around the sun, and heading on back out. If you get a chance to see it, it's beautiful. Absolutely worth taking a look. So this is a long period comet. There are also, went backwards. Now, these short period comets, so the short period comets are 200 years or less in their orbits, are thought to come from something called the Kuiper belt. The Kuiper belt is actually a sort of a disk of stuff. That's the scientific term. Remember I said I didn't have a PhD? Right? So there's a bunch of stuff out there. By the way, that yellow circle is the orbit of Pluto, which is one of the many reasons why Pluto is no longer considered a planet. It's not orbiting in the same plane as all of the other planets. Well, outside the farthest reach of even Neptune is this ring of stuff. And it's all just a bunch of icebergs floating out there. And if two of them bang together and one of them says, oh, I'm going to go this way for a little while, and it gets sucked in by the sun and eventually whips around the sun and comes back, and we get to see a pretty comet. Now, the long period comets are thought to come from something called the Oort cloud. Now, this is a fun picture because if we're looking at the Kuiper belt, that's probably about here. And this is actually where Voyager is. Now, Voyager's that's the one that took that cool picture in 1979, right? Hurtling out into deep space. The scale on this image is not linear. This is a logarithmic scale. So if you look here, it looks like Earth to the sun is the same as Earth to Saturn. Well, these are astronomical units. 93 million miles is the distance between the sun and the Earth. We call that 1 AU. So it's 1 AU between sun and Earth, but it's 10 AUs between the sun and Saturn. Right? An order of magnitude. So this is a logarithmic scale. So it doesn't really kind of give you the feel for how big this Oort cloud is out here. But if you look thinking of logarithmic scales, that's 1,000, 10,000. This is a big thing. Here's a better picture. Here's a solar system on the inside. Here's that huge Kuiper belt. And here's the Oort cloud. This giant ball of stuff. Almost like something exploded and made all this debris out there. Weird, right? So, the Oort cloud is so large that Voyager will not be there for hundreds of years. It has also never been directly observed. So it's kind of a theoretical thing because these comets keep coming in from all over this place. And like, there's got to be something out there. We call that the Oort cloud. Now, the center of a comet, that dirty iceberg part of the comet, we call the nucleus. And that's literally like a giant iceberg. And this is a picture taken from a NASA mission where they did a flyby. They actually sent a spacecraft up there and got close to a comet and took pictures of it. How crazy is that? I'm not a math guy, but just thinking of the math makes me cry. All right? So this is 2 kilometers in length. The distance between here and all those potholes that you drove over from the main road, right? It's 2.5 times that. So that's how big this thing is flying through space. And that's not even a big one. I heard somebody mention the other day, like, well, all comets are spherical. That is not true. Anyone thinks that there's a picture of one, it's not a sphere, okay? The tails on the comet always point away from the sun. So when they're coming in, the tails point away, and as they slip around and then they move out, the tail is actually in front of the comet. Because the tail is caused by the solar wind and radiation coming from the sun, which is causing all this ice and stuff to sublimate. Sublimation is the act of a solid turning directly into a gas without having gone liquid first. So if ice melts, like dry ice, have you ever seen dry ice and you put it on your counter and then there's gas all over the place? That's sublimation. So comets are sublimating and all this gas is spewing up, and the sun kind of lights it up in a couple of interesting ways. Comets have 2 tails. They have a dust tail, and this is called the plasma tail, which is also sometimes called the ion tail. There's also the nucleus down here. When you see a comet, you don't really see that iceberg. You see all of the gas and the plasma that's getting excited and being visible. Some of the tails can be over 1 AU in length. That's 93 million miles. Some of these comets, if you go out and look at Lemon right now, some people are reporting that it's multiple full moons in length. That's an enormous thing to see in our night sky. Comets are super cool, and there's more of them than you think. We have now seen 3 interstellar objects come through, which is kind of exciting and got a lot of people talking about some weird things like they're spaceships, and they're not. All right? We call these objects hyperbolic, and that's because they don't actually have an orbit. They don't close the ring. They come in, they bend a little bit, and then they move on out. So this is actually the orbit of 3I Atlas, which is the one that everybody's ranting about right now. And you can see it actually came pretty close to Mars. Bam. And it was only last month, I think. This is not a new thing. People are like, this has never happened before. It's estimated that probably 10,000 of these things happen a year. We just never could find them. We didn't see them. How could we possibly know? You heard been talking about Vera Rubin before, taking pictures of the entire night sky. Oh, there was a dot, and now there's a dot here. We didn't have that dot on our record. What is that? That's how we're starting to discover. You're going to see more and more of these things when we've got instruments like that that are examining the entire night sky. Okay, so now we're going to talk about the comet. This comet named Shoemaker-Levy 9. And it is named after Carolyn and Eugene Shoemaker and David Levy, who's standing in front of this really sweet Questar 3.5-inch telescope for any of you gear nerds out there. Comets are named such that they get an identifier right here, whether they're periodic, non-periodic, no reliable orbit, or broken. And we're going to talk about that in a minute. Or reclassified as an asteroid, then the year discovered, the half month, and then how many within that time frame. They used to just name them after the person and then put a number after it, and they decided they needed something more scientific. That is the telescope that the Levys used. By the way, if you want a really cool story, look up Carolyn Levy, because she was not an astronomer, and she was working at home and felt unfulfilled, and her husband's like, let's do astronomy together. And then they went and discovered like a bunch of comets. It's really, really cool. Okay, so this comet was the first time that they had discovered a comet. It was a little bit different than all the other comets. Remember all the other comets I talked about, had this nucleus, right? This dirty iceberg in it, and coma and tails and all this other stuff. This one looked weird, right? And they discovered that it had actually broken up into multiple parts. How did that happen? Well, they actually also discovered, once they could plot its course, they figured out the orbit, and they discovered that it wasn't orbiting the sun. It was orbiting Jupiter. And we had never seen a comet orbit something else before. So Jupiter, at some point in the past, had captured this thing, maybe saving it from slamming into us. No, just saying. Right? And broken up into multiple pieces. They also soon determined, when plotting the orbit, that there was a 99.99% chance that it was going to slam into Jupiter. And the entire astronomy world went, oh my God, right? And I get tingles just thinking about it because it was a big deal. We had never witnessed an interplanetary impact in real time, ever. We see craters all over the moon. Clearly they've happened, but we've never seen them happen. So, holy crap. So in 1994, this huge breakup happened, and it was, wait, that's not the right ones. Hang on. Okay, so the comet broke up, but it did not break up in 1994. It actually broke up in 1992. And what happened was it got so close to Jupiter that the tidal forces of Jupiter put so much stress on the iceberg that it broke into pieces. It didn't exert enough gravitational force to pull it into Jupiter, but now all of these pieces were in orbit. And as the pieces evolved over time, you can actually see them spread apart, right? This is March, April, May, June, July, and you can see them spreading out as all of the forces. Now, these are, by the way, this picture is from Hubble, this picture is from Russia, this picture is from Germany. The entire world pretty much stopped what they were doing to check out this comet. All right? It got named the String of Pearls because that's kind of what it looked like. This Hubble picture is freaking magnificent, right? That is an actual picture that Hubble took of all of these comet remnants getting ready to slam into Jupiter. Now, when I say there was hype, it was on the cover of every major magazine, news or otherwise. There was a full-page spread in the New York Times. The internet was not a thing, so we actually had to read like paper to get our news. But I'm not joking. Like John said earlier, people would come and ask me about it at work because, like John, I was the astronomy guy. I actually wrote a little brief report about it and put like 100 printouts on top of the trash can in the cafeteria. And people just ate it up because everybody was curious about this. Astronomy is not a thing that everybody is curious about all the time. But when something like this was happening, man, it was a big deal. It is hard to overstate how big of a deal it is. Now, I had a tangent before about Galileo's telescope. I got another one about imaging Jupiter because look at that picture. Holy moly, that is amazing. That picture is from the Juno spacecraft, which is orbiting Jupiter right now. That is Juno. It was launched in 2011, which, wouldn't it be great if we had pictures like that from when the comet crashed? Yeah. Well, the comet crashed in 1994, so it was 22 years too late. Now, I need to point out that, remember I said that all of Jupiter's moons are named after his many mistresses? Juno is named after his wife, because Juno had the power to see through the clouds that Jupiter created to hide his mischief. How cool is that, right? Oh, I love that. This is actually the orbit of Juno, which I just had to put in because it's such a cool image. But Juno actually orbits over the poles of Jupiter. Most of us, when we think of orbit, we think of a horizontal plane going around the equator. Juno doesn't do that. Juno actually goes over the top and actually rotates around it. And the reason for that is that Jupiter has the largest known aurora in the solar system. And the reason it has the largest aurora in the solar system is because it has the largest magnetosphere in the solar system. And its magnetosphere is actually focusing radiation belts like you wouldn't believe. And when they designed Juno, they actually call it a tank in space because they had to design it to survive all of this stuff. And we get those amazing pictures we have. So going back to trying to take pictures of our comet crash, this is 1994. So here's a bunch of really cool orbital telescopes that you may have heard of. None of them existed. was 1994. All of these things were new in 1994, which was a long time ago. None of them existed yet. So what were our options? That is an actual ad from Orion Telescope. Sadly went out of business this year. But look how happy he is, right? He's seeing, right? That telescope, by the way, that cheap hobby killer telescope, better than Galileo's. In 1994, we had really cool telescopes. That was my telescope. I wish I still had it. That's my buddy Sal in the background, who's got his own telescope. We are not taking pictures of the comet here. We're actually taking pictures of a annular solar eclipse. I've got my little Pentax K1000 film camera on the bottom because we took pictures with film and we had to get them developed and hope they came out. There was no looking at the screen. Wow, it was a good picture and moving on, right? No, it was all film. But we couldn't really, it wasn't really a great setup for taking pictures of a comet slamming into Jupiter. But the hype was enormous. We needed to take pictures of it. Thank God Hubble was up there. Hubble had just recently been put into orbit and almost immediately discovered that the primary mirror had a spherical aberration. So now we've got this big, beautiful space telescope and it's broken. Well, NASA did what NASA does, and they went up and they fixed it. Now, Hubble was actually designed such that the wide field and planetary cameras could be swapped out. So they put a new one in that actually had a filter that compensated for the deficiency in the primary mirror. Wow. And that's actually wide field 1. Wide field 2 that they put in is actually now in the Smithsonian. I don't think you can see it, but the Smithsonian owns it. Very, very cool. 25 hours of spacewalk time to fix the camera. And the comet crashed into Jupiter 7 months later. And that was absolutely amazing. So, now we're going to talk about the crash. It's why we're here. I love this picture. Because this picture is 1994, right? There's no giant screens. There's no big, beautiful laser projectors. There's these monitors blowing radiation in our faces. And this is actually Dr. Heidi Hammel, who actually led the team for Hubble to take pictures of the comet crashing. And she is literally taking her pencil and pointing and saying, "Is that a moon? That looks like a moon." And somebody yelled behind her, "Let me look in the almanac," because we look at a book. And that's not a moon. And that was the moment that they witnessed the crash for the first time with the pictures being sent from Hubble. There's actually a video, there's a link on the bottom, there's a video of them from another angle actually realizing it's the crash. And the joy on their faces is palpable, unbelievable. Imagine getting all of these resources together to be able to take these pictures. So the comet crashed into Jupiter. Right? Now remember, there's like 26 pieces of it. And it started crashing into Jupiter. And it crashed into the far side of Jupiter, so we couldn't see anything. What? Well, the cool thing is, remember this? Jupiter turns around every 9.9 hours. So we actually got to see some very cool pictures because we'd see things from the edge. This is infrared. Infrared means heat. If we're seeing that kind of heat signature from Jupiter, woof. All right? This was an absolutely enormous event. This was taken by the NASA's Infrared Telescope facility on Mauna Kea. And here's a fun bonus pick. That's me standing on top of Mauna Kea, and that is, in fact, the NASA Infrared Telescope facility. Pure, absolute dumb luck. I went and looked through my pictures. I was like, I've got a picture of me standing in front of it. And I put that in at like 11:30 last night. Okay. Impacts continued for 6 days. Look at this. This is Jupiter spinning around. Bam, bam, bam. Amazing. Now, this was a state-of-the-art scientific instrument. A 1024 by 1024 pixel infrared camera. That's 1 megapixel. It was 1994. This is a 1997 home digital camera that you could buy. I have one. And you know what? It still works. It takes 4 AA batteries, but it was 1 megapixel. This was spill-off from all of the real science that was happening. Right? Jim just talked earlier about 35,000 megapixel, whatever. That school bus-sized camera has an enormous camera on it. Back then, we didn't have that, right? We just didn't have it. Today, you can buy a 62 megapixel camera for your telescope for $4,000. Right? But we didn't have that back then. So, after the crash, remember, Jupiter is spinning once every 9.9 hours. And that was cool because now we could start seeing scars from each one of these impacts. And that was actually pretty amazing. We could see them in ultraviolet. All of these pictures, by the way, taken with that camera that NASA just replaced. We wouldn't have any of them if NASA hadn't gone up there and spent all the time to fix that camera. As the days progressed, we could start to see these impacts, right? So this is 5 days after. If you look, here's the first impact, and then we see what actually looks like a crater. There's a dark spot in the middle, then there's a ring around it, and there's debris around the outside. It's exactly what craters on the moon looks like. But Jupiter is a gas giant. So what's going on here? Well, if you think about throwing something into a bucket of water, it's going to splash like that. Craters do the same kind of thing. We have an ejecta plume in the center. We send debris out onto the outside. Now imagine that with an iceberg traveling at 134,000 miles an hour. To put that into scale, a rifle bullet, probably 2,000 miles per hour. So here's this iceberg slamming into Jupiter. The amount of energy released, simple formula, force equals mass times acceleration. Now, this picture is actually from an article talking about the asteroid that killed the dinosaurs on Earth, which is relevant because each one of these impacts was equivalent to an extinction level event on Earth. And there was multiple over 6 days. It was an absolute unbelievable thing to witness. When that big boom that happened, right? The temperature in the atmosphere went to 53,000 degrees Fahrenheit. The surface of the sun is 9,000 degrees Fahrenheit. So this was hot, right? That was a big, like I said, a mass extinction event if it were to happen on Earth. Now, to be fair, this is a little bit hyperbolic, a little bit of hyperbole, if you will, because this is actually the coldest part of the sun, right? The photosphere of the sun, when you get out into the corona, it goes up into millions of degrees. But it's still fun to say that for a brief while, Jupiter was in fact hotter than the sun. So, some things that we learned from this, right? Because this thing smacked into Jupiter. And as it went down, if you think about the physics of a snowball hitting water, it goes down and stuff that was underneath the surface got dredged up, which is something we had never seen before. So the scientists were going crazy because they were seeing things from inside Jupiter that we had never seen before. Additionally, we got to watch as the bands on Jupiter spun around. We got to discover how these things dispersed over time, which gave us information about how Jupiter works in a way that we couldn't have figured out otherwise, which was really, really wild. These explosions went 1,900 miles up into the atmosphere. That's really high. Okay? This remained for weeks, and the scars continued over weeks and weeks and weeks. And John and I had the similar experience where we were like, you're not going to be able to see anything. You could see things. By the way, that's the size of the Earth. And if I can, I'm probably going to go out of frame here a little bit, but I'm going to hold up my little Earth ball there, right? So this is the Earth compared to Jupiter on the screen. All of us living on this little ball, this little blue marble, and each one of those explosions was the size of the Earth. That's the kind of scale we're talking about. Amateurs did take pictures. Now this guy took a picture with a 17-inch Cassegrain, which is not as big as a telescope upstairs, but it's bigger than any telescope I've owned. And he was using that same Pentax K1000 camera. And he got a picture. It's actually upside down, but you can see the scars up here. We didn't have the super cool digital cameras that we have today. We didn't have all of the super cool stuff that we could take pictures with. But it was still kind of fun. 2 weeks after the impact, look at how the impacts have dispersed and they're spread. This gave scientists the ability to learn more about how the gases are moving on Jupiter. It learned more because they actually discovered gases coming up from underneath that they had not previously measured. And my understanding is that those gases are still present today. So 30 some years later, we're still seeing results from the impact. What was the tangible impact to society from all of this? 2 major motion pictures were created, Deep Impact and Armageddon, absolute masters of their class if you've seen them. That is, well, so let's talk about subsequent similar events, because that is not the last time it's happened. We actually have pictures in 2009. Hubble took another picture of they didn't see it happen, but they noticed the scar. Wow, interesting. Amateur astronomer in Austria was filming Jupiter and noticed this on one of the frames. Yeah, right? It's like an ejecta plume, something smashed into it. It's amazing how astronomers, amateur astronomers, are often the ones to discover these things, because we're constantly taking pictures of all this stuff and taking movies and whatnot. Here's another one, 2021. This was from Japan. You can see this little white dot up here, and this is it over time. And you can see that it's a little boom that came up. And they can actually figure out the size and the energy released during the impact. But it is now estimated that, I like this, on average 6.5 objects 10 meters across and larger are hitting Jupiter every year. So where the Comet Shoemaker-Levy 9 was the first time we ever saw it, we've now seen it subsequently. And again, we have better instruments, we have better, facility to see all these things. And that's not even all of them. This is a Wikipedia page showing all of the impacts for devices on Jupiter, including this one in 1979. Wait a minute, I thought we said we had never seen one before. Well, it turns out that as Voyager flew by, it actually recorded a rapid flicker of light. And we have now determined that that was very likely the first impact that we had ever recorded on Jupiter. Comets frequently break up. It is actually, it actually happened a year or so ago. One of the comets that were like, it's going to be the big, most beautiful thing ever, and it got too close to the sun, and it just crumbled. And generally, when it crumbles like this, you don't get nearly as beautiful a tail as you would if it were still intact. But that is just such a beautiful animation that I couldn't not include it. This has happened previously, and we have proof. This is on the Jupiter's moon of Ganymede. And if you look at this string of craters, this is quite clearly from a string of things slamming into the moon as they are moving forward and or the moon is turning, right? So we have history of another broken up comet slamming into something. Here's another one from Callisto, another one of Jupiter's moons. And if you look down here, you can see this long string. So this was a big one. These are close-ups of individual craters. That is quite clearly a very long time ago. This is the asteroid Vesta. Here's a string of craters up here. Now this one, I should point out, they can't prove whether or not it was craters or if it was just something ejected from a volcano somewhere else. Also possible. Or an impact crater. Possible future impact events. Near-Earth asteroid 2024 YR4. Has anyone heard of this? It was on the news for a while, right? She's like, yeah, right? Because there was a point where it's like, yeah, it's going to slam into Earth. And we're like, wait, what? In 2024, or now, we have now fallen from level 3 to level 0 on the Torino impact scale. And we're all like, whew. Wait, there's a Torino impact scale? And there sure is. And it was at 3, and that's only yellow, right? So if the news starts talking about this stuff and there's a Torino impact scale level 8 thing, maybe go back to bed. You probably, it's not worth worrying about. Now, what's cool about this is it is currently determined or currently estimated that in December 22nd, 2032, here is the asteroid, this is the Earth, and this is the moon. And right now there's a 4% chance that that asteroid is going to smack into the moon. And if that happens, it's going to be amazing. Now, you're all sitting there like, that sounds really bad, right? It doesn't sound amazing at all. Well, the moon is pretty big, and the asteroid is not as big as the moon, so it's not going to cause some cataclysmic thing, but it's going to be visual, right? Because this is a fairly large object, and it's also going to make an amazing meteor shower later on. And when things get bumped up from the moon doesn't have an atmosphere. So all of that stuff from the moon goes into space. And sometimes the Earth goes through that. And we actually get meteorites that are pieces of the moon. And if you're questioning that, we have a meteorite display in the back that has a piece of the moon in it. And it's not from an astronaut that brought it back. It's a meteorite. There are meteorites from Mars as well. It's crazy. Mark your calendars, though, 2032. All right? Stuff hits the moon all the time. Well, if you look at the moon, it's covered in craters, so that seems pretty obvious. But we haven't seen any impacts that would cause the giant craters like we see when we look in a telescope. However, we have recorded a fair number of impacts on the moon. So if it happens on the moon, could it happen here? It already has. There are strings of craters. Here's one in Missouri. There are strings of craters in Chad. This is actually radar imagery, so they're not visually obvious. So if there's been strings of impacts, does that mean single impacts? It's already happened. There's a place in Arizona called Meteor Crater. And of course, the joke is it's a good thing that that meteor hit and missed the visitor center, right? Wow, that was lucky. There's actually a really cool NJAA talk about, I think it was Chesapeake Bay. It was actually formed by a meteor impact or something, given by another QO member. So worth checking out. That almost never happens, right? This is the Earth impact database as of 2024. And these are all known major impact craters that have happened in the past. This, if you've ever seen that name before, is the one that we believe killed the dinosaurs. Right? So stuff has slammed into the Earth. But again, you don't need to worry about that. Doesn't happen too often. These are bolide events. If you never heard the term bolide, a bolide is basically like a fireball in the sky. It's something big enough that it actually lights up the sky as it goes across. You may have seen YouTube videos recently. There was one in Russia. There's a couple others. Usually come with like a big sonic boom or something. I've seen one, maybe two in my life, and they are amazing if you manage to catch one. But those happen fairly frequently too. So how about the actual impact to society? The actual impact to society is that, thanks to this comet impact, NASA and other world groups bonded together and created the Planetary Defense Coordination Office. And they track near-Earth objects that could potentially have slamming into us, right? So, the good news is, how many could there possibly be? Well, it turns out there's a couple. Now, I need to point out, because I love this image, because you look at this image and you're like, oh my God, we're all going to die. There's a scale problem with this image, all right? These objects are very, very small. And this picture is showing every one of them as basically a pixel, and it's also showing the sun as a pixel. So the scale is completely off. It's a great picture to raise awareness of how many objects, because this is starting to look like in WALL-E when they go through the atmosphere and all the junk is in orbit. It's not like that. However, all of these things are actually being tracked. So it's kind of cool because these are being tracked because of Comet Shoemaker-Levy 9 being slammed into Jupiter. Because all of these organizations were like, we should probably pay more attention to this. Space is big, right? All these things we're talking about, space is so unfathomably large. It is literally astronomical. It is very difficult for us humans to conceptualize how far apart these things are. And it is a very, very big deal. Now, I would say, don't worry about it. Don't worry about it. But keep looking up, because you just never know. And that's actually the end. So, any questions? Anyone? I am open to ask anything, even about, yes?
So, the asteroid or whatever it was that was hitting Jupiter,
Mm-hmm.
did it make those marks
No, actually, so that's such an interesting question. So the Comet Shoemaker-Levy 9 had actually broken up into about 25 different pieces. So each one of those, as Jupiter was spinning, another piece would hit it, and then another piece would hit it, and then another piece. So those are actually, yes, so it's actually, each one of those is an impact from one of the pieces from the comet. Yes?
How many years did you were showing over time,
Hmm?
you know, that the thing was expanding and it looked interesting. How long did it take to actually disappear? I mean, at this point, if you look at Jupiter,
The scars on Jupiter?
yeah.
Yeah, I don't believe you can see any remnants of it at all, but the scientists can actually measure chemicals in Jupiter's atmosphere that they couldn't before. So it has dredged stuff up, but you can't see them on a telescope, or Hubble can't see them anymore. Unfortunately, because it was really cool. Yes?
Do they monitor like future solar storms, like the Carrington event and stuff like that?
Yes. So there are multiple instruments up in orbit that are looking at the sun constantly, and there will be notifications that the sun has gotten more active, or the sun is releasing, forgive me, a prominence or something, right? It's ejecting some sort of stuff.
It's like a new active period. The
Yeah,
next
yeah.
year or two.
So that is absolutely being monitored. Someone else from the club might have a better answer than that, than I have for that. But yes, absolutely being monitored. Another question? Yes.
How old was that light that we captured that event?
From Jupiter?
Yes.
Well, that's a good question. Anyone know the distance to Jupiter and how long light takes?
Couple hours.
I would think. Yeah. That's a good question. Now I feel totally unprepared. I don't know. It should be a fairly easy thing to look up, though. If you look up how long does it take light to get from Jupiter to here, I'd be interested if anyone looks that up to let me know. Anyone else? Nope. None? Well, thank you for coming. It was a pleasure. I absolutely love doing this kind of stuff. I learned that this is the last talk for the year, so that's I'm going out with a bang here, I guess. But again, thank you for coming. If you ever have any questions about any of this stuff, you're welcome to email me. I am addicted to email, so I am almost always answering my emails. And if there's anything else,
Thank you, Dan.
thank you.
Thank you.